Alright. Hi everyone. Welcome to CS37. I'm sorry I missed last week's first week of class, but this is our first week. So I sent out an email to all of you who enrolled in the class. By the time I sent it out, that was last Tuesday, that the quizzes for syllabus was already open on Canvas. So I'll briefly go over this. Most of you have already seen this and took the quiz. Okay? And then before that, I'll talk a little bit about myself. My name is Jen. I graduated and transferred from IVC a long time ago, and I took some of the classes that you're still taking right now, taught by the same professors. Okay, so I know the program. I transferred to UC San Diego in computer science, finished my undergrad and grad school over there, came back to Irvine because I love Irvine. Now working in a local game company here. Started as a data scientist, machine learning engineer, and now I manage the data science team at the game company. Okay, so I know data science, I know software engineer, I know machine learning, so a lot of students come to me after class to ask questions about the course, and also outside of the course, about transfer. Everything's welcome. Okay, so I'm a part-time professor, so I still work in the gaming company right now. So my class is at 6, so I come here after work. Therefore, I do not have office hours. Compared to a lot of full-time professors who do have an office, I don't even have an office. I was having a hard time finding that pen because I don't have an office. I don't have pens. So if you have any question on the project or want to reach out to me in person, I'll stay here after class until I finish all of your questions. Okay, so that is your chance to ask me anything, show me your code, or just ask me anything in person. Okay? So that's different kind of between this class and the other CS37, also hosted in this classroom, I believe, in the morning. We have once a week class, so 6 to 9. I normally will not go all the way till 9. I will leave time for office hour or for questions. The class will start from 6, most likely finish around 8. Okay? For this one, we will have a lab. We have 4 labs total. The lab will come after the lecture. So I'll talk about, so today we'll talk about Intro to C++. Once I'm done with that, we'll have lab 1. The labs are required, although there's nothing for you to submit. The reason those are required is because if you don't do the labs, you will not have the right environment to run your project assignment. So I have lab 1 and lab 2 to set you up to run project 1 and 2. After that, I have lab 3. If you don't finish lab 3, you will not be able to run project 3. So a lot of people were in a panic, email me, like, oh, my compiler doesn't work for project 3. It's like, because you need to finish lab 3, okay? So those are required for you to actually run to test your code before you submit the project assignment. So they're required, but nothing needs to be submitted. So you'll see that today, that asks you to write something, but you don't need to submit anything. Okay? It's just a tutorial kind of to help you walk through how to set up your compiler so that you can start running your code for projects. All right. There should be a one single page, 2-sided for you to sign. I do take roll for the first 3 weeks, I believe, because if people don't show up, I need to drop them so other people on the wait list can come in. Okay? After that, I will not be taking roll. Lecture is highly, highly recommended, but I know that C++ is not an easy thing. What I wish to happen when I was in school is everything to be recorded. So luckily, the past 3 years I've been teaching online. So everything was recorded through Zoom, and there's also a transcript that IVC helped me put in. So for this class, although I'm not recording for live this class, I will be uploading recording from last semester to Canvas. Okay? Some of the video that I uploaded, I have seen people of a 50 people class with view times more than 150. Because that is how many times you can go back and look at them to try to understand, oh, what is this that's happening in C++. If I want to plot out the difficulty of the class, it will start pretty simple. I'll do review and introduction. After midterm is when we get into classes. and then the difficulty just shoot up, okay? You will see me start to review every time before I start the class on what happened last week, and talk about what happened this week, tell you what will happen next week. It's because I know those are all new concepts. It's very hard to understand. You can see the slides being short, but I will spend time over and over again to talk about them, okay? So participation, highly recommended, but it's not, I won't take from, so it's not like forced. I don't force you to come to class. For the first couple weeks though, if you're gonna miss a class, please email me. So I know that, okay, you're still in the class, I'm not gonna drop you, but after that, you're fine, okay? All right. So I will point out a couple of things from the syllabus. Textbook is not required, although I did use this book to develop the course contents. Okay? So if you don't think the slides content is enough to explain what's happening, you can refer to the textbook, but everything that I ask you to know should be on the slides. Okay? So completely optional. I know that different people have different systems. Some of you use Mac, IRDC, and some of you use Windows. I have a Mac, and I do provide screenshots of code in the slides, so you'll see very soon. Those, if you see it a little bit different, it's because I have a Mac. So for those of you who have a Mac, you will see exactly the same interface. For those of you who have Windows, it's fine. Okay, like I have been asking Windows students from the past to send me screenshots the best they could, so I try to include some of those. But if you see me live demoing and be like, that's not what I see, it's okay. The code should be the same. If it runs on Mac, it should run on Windows, as long as you follow the labs. Okay, as long as you follow the labs to set up your software the way I asked you. All right, what do we have in this class? So we have quizzes, 1 midterm, 1 final exams, 3 project assignments, and 1 final project. And we also have extra credit. So for this class, I do not accept late without penalty, meaning that all of your late penalty is deducted automatically by Canvas. So if you're late by a certain amount of time, you see your point deducted. I did not go in and change that, okay? Everything's deducted. However, there's a total of 8% of your total grade that can be extra credit, meaning that you can purely use the extra credit to bump your grade from one level to another. Okay, 8% is a lot. Quizzes, all together, 3%. Okay, all optional. All the quizzes are due right before class. So say I teach about Intro to C++ this week. Next week, before I talk about the new things, the quiz for this week will be due. Okay. No late is accepted, it's extra credit. So if people email me, oh my god, I missed this one quiz, it'd be like, don't worry, you missed about 0.3 or 0.08% of your extra credit. So don't panic if you miss a quiz, or want to ask me to open up a late quiz. I actually cannot. So quizzes are optional. All together, worth 3% of the extra credit. Midterm will happen around week 9, final will happen at final week, all on Canvas. I will open it up in class. So on the day that we have midterm, on the day that we have final, please come here so that you know when we open it up. Technically speaking, you could do it on another computer somewhere else, but you just won't know. You will have to sit there, wait to see when I open up, because I will talk about things and I'll open it up and everyone can do it at the same time. We have 3 total project assignments, project 1, 2, and 3. Each of them will be due in 2 weeks' time. So you have 2 weeks and a little bit of time to submit it. Each day late is 20% deduction, okay, which is a lot. So you have 2 weeks, which is totally enough of time if you actually start 2 weeks ago. So if you start 2 days ago, I cannot guarantee, okay? If you come in late, you can come to sign this after class, so don't worry about it. Okay? Final project assignment, you have more than 3 weeks to do it. Final project assignment is the one that I'm trying to use to transit you to the next class after CF37. I believe it's 41. Okay? a big project. That's why you have more time to do it. So that is the final project assignment. It itself worth, I think, 25% or 30%. Yeah, here's the grade breakdown. So quizzes altogether 3%. You have an extra credit project assignment between project 2 and project 3. It's extra credit. You only have 1 week to do it. Okay. It also does not come after final. So if you want to be like, I want to see what my final grade look like before I do extra credit, you cannot do that. Okay. It's still before I release to you project 3. So if you anticipate, as I already told you, this class will go exponentially harder toward the second half. If you want to give yourself 5% buffer, please do the extra credit project assignment. 3 project assignment altogether is 50%. Final project is 25% alone. So you can see that's a big project. And we'll have midterm and final. Alright, everything else is pretty standard. Do you have any question on syllabus? Yes?
What are the dates for the 4 labs?
The dates? Oh, like when will they happen? This week is lab 1, next week is lab 2. I don't know the specific date for lab 3. That will be between project 2 and project 3 because that's what I use to prepare you to run project 3. And then I think lab 4 is right after that. If the date will be helpful, I can go figure out and post that.
Thank you.
Okay, yeah, we'll do that. Any other? Yes.
You mentioned that there's going to be in lab 1 setting up the compiler. Do we have to do it through VS Code or can we use another compiler as long as it's code?
That is a good question. VS Code is highly recommended because all my screenshots were taken through VS Code. Let me tell you a little bit why I choose VS Code. So I have been using Visual Studio for the furthest time until I graduate and I lost access. Okay, so for a student, you have access to all of them, but when you actually go to a company, it depends on whether that company uses Visual Studio. VS Code is very common. I use it for my work even like that. So I don't want people to kind of fill the gap like I did. So I decided to just stick with what I use in the industry. So hopefully that gives you an easier transition into that. But I know there's a lot of other classes still use Visual Studio because I took those classes. It's fine. However, Visual Studio is a more tolerant on code, meaning that if you miss some minor things of, oh, I forgot to set my initial value to 0, and I start adding to it, Visual Studio will be like, oh, that's fine. I forgive you. I'll set it for you. VS Code does not do that, okay? I think one of the reasons probably, like, VS Code just do not assume anything. If there's an error, you have to go in and fix it. It will say, hey, no, this is wrong. You fix it. Visual Studio, it's very forgiving. But when I run your code, I do use VS Code. So for the people who use Visual Studio, you then need to use your own discretion to check your code because your compiler may not be able to help you as much to point out things that may not work. That's why I recommend using VS Code. All my labs are helping you to set up the environment in VS Code. Unfortunately, I will not be able to do that for Visual Studio. So if you are very familiar with Visual Studio, you feel very comfortable setting all those in Visual Studio yourself, go ahead and do it. But if you want to, swap to VS Code, this is the right time because I will walk you through it like you just freshly installed it in that way. Yeah? And yes?
Oh, so like in regards to like labs as well as, projects and exams, how can we prepare for that? I know like the quizzes are extra credit, but is that really reflective on like what's on the actual exam as well as the projects?
That's also a good question. Quizzes, the problems on quizzes are very, very, very similar to your midterm and final, which is also the reason that I will not be opening up all your quizzes right before midterm so you can just copy and paste, okay? If you want to better prepare for midterm and final exam, doing the quizzes is a good way, a very good way to do it. For project assignment, I provide a lot of code examples in the slides. I even made project slides with more code examples that as long as I have them on the slides, you can use those code as it is. I will not be like, oh my God, you copied my code. Like, no, okay? So if I post that, be like, okay, this is my project 1 slides. There's definitely going to be screenshots. of like, you can do it this way, you can do it that way. It may be a little bit different than what I asked you to do, but very, very similar. You can use those code assets. A lot of people ask me a question and be like, it's in the project websites. If you go and attend class, you will see that and you can use it directly. So those will be a good way to do it. However, final project, I do not provide that. I'm anticipating you to independently finish final projects, but you can always come to me with your half-finished code or unable to run code. Ask me to help you debug live here, or send me a screenshot of your error message and be like, where can I start debugging this error message? That's another way that I can help you with your projects. Yeah.
So are we just going to submit right onto Canvas, or do we have to join a repo of any kind?
No, so you will submit right onto Canvas. Every time the project assignment will tell you what file is expected. So if it's .c++ file, that will be what you can submit. Later on, when we talk about classes, there will be different formats. It will specify on Canvas and be like, you are expected to submit this file and that file. So everything is submitted through Canvas. That's also where the late deduction will happen because they have the timestamp of when you upload your files. Okay. Project assignments are all due at midnight. I know some people hate professor to have things due at midnight. I also know that I code very efficient after 6 p.m. until midnight. Okay? So I want to give that freedom to you. If you don't want to do your code at 11:55, start early. Okay? Also, I guarantee you, at 11:58 p.m., the clock will tick faster than you expected, and then the minute that you submit it, the clock tick, and you're out of 1 minute, you have 20% deduction. You're gonna email me and be like, oh, my internet was slow. I'll be like, nope, I'm just the way it is. So please don't submit last minute because everyone's doing it at that time, okay? Even though I've been telling every of my class, please don't submit at 59. Everyone do it at 59. You're jamming each other's, okay? Canvas be going out of control. So please submit it. Even at 11:58 will be beneficial. Or 57 or 56. As early as possible when you submit on Canvas. Yes. Good. Any other question? Oh, one thing that I do want to point out, plagiarism. Code plagiarism is so easy to happen. I already know a lot of my project assignment is up on track. Okay? I'm telling you right now, the solution is wrong. And I know the solution when I see something like, I didn't mean to grade this is from check, this is wrong, okay? So please don't copy from online resources. I do change my project assignment a little bit every semester. And the check was probably uploaded like 2 years ago or something. Okay, so it's a lot different than what's out there. And believe me, even when I work now, when I just look at the code, I know who wrote it because every programmer has their own signature, which I'll teach you about developing your own signature as a programmer this semester. But it's very easy to tell that, oh, those two codes with different variable names are from the same source. I don't know where that source comes from, but they're from the same source. Okay, everyone, please write your own programming assignment. If you just change the variable name, I will know. Okay. Other than that, I think that's all for syllabus. Let me walk you through. I haven't published everything yet, but I can walk you through a little bit of a preview of what each module will look like on Canvas when I open them up. Actually, I can open up right now. So labs will all be here, okay? And then you will have modules for each. So I'm gonna hide those for now. You have modules for each chapter. So there's Intro to C++. In addition, the recording, which I just published, will be available after class. Is this shaking? Oh, yeah. That's unfortunate. Okay. We stop. I don't know what happened. But so yeah, so each module will have the slides, quiz, recording. Same be for basically all of the modules. You can see sites, quiz, recording, sites, quiz, not quiz, project assignment, recordings, midterm, and so on. So I do group some of the important things under one module. So you see the classes that we teach right after midterm. We spend 3 weeks on it. I'll group them all together because they're all about classes. When we are grouping things together, we will only have one quiz that you see down here. So I will not give you 3 quizzes, because one quiz per module. Yeah, so that would be what the modules all have. I believe if you go to Syllabus, you should be able to see all the due dates already. So you can kind of better prepare for it. Yeah, that's it on Canvas. All right. So none of the things that I just said were recorded. Okay. Starting now, the recording that I just released will be the recording of the slides and my explanation of the content and things. Okay. So today we have 2 things to English, which is C++ provided back in 1979. So design goal for C++. It was at that time still designed to be a system programming language, meaning that it can not only support high-level application programming like we do nowadays, it still needs to support low-level system programming because that's what people were all doing at that time. There are some requirements for C++ back in 1979 is that you need to be able to compile down to machine code efficiently on the machines of the date. That is not machines that we have today. Okay, it had memory of just kilobytes, and then it had maybe just megabytes of disk, which is unthinkable of right now. Even your phone has megabytes right now. Another thing when C++ was developed back in the day is that C was really, really popular. Okay, if you develop a new language that's not what we call backward compatible, people will not use this new language and abandon all the things they wrote in C. So it needs to be compatible with the dominating language at that time, which is C. So C++, a lot of the feature was developed to be compatible with C, so people have an easier time to transition into C++. All right, C++ basics. This is about how we run C++, which is different than C. C++ is always triggered by a function called main, no matter what that is. Okay? It doesn't have to be the first function, but it's a function called main. The name of the function is main. That main needs to return a value. Each program that runs on Windows or Mac or Linux always return a value to tell your operating system that I'm done, or I failed, or I have an exception, or I finished successfully. And that code for C++ is 0. Okay? 0 means to your computer that, oh, this code finished successfully. Finished running, you can use the RAM to do something else. So you always see me have return 0 as the last statement in the main. This is something that Visual Studio does not require. Visual Studio will forgive you for forgetting to return an integer, and it will return it for you. But when I bring that code to my computer and run it under VS Code will be like, are you done? Like, are you returning anything? Am I waiting here? You know? So that is something that the people who want to use Visual Studio need to be a little bit careful. Is remember to return 0 at the end of your main function. Your compiler will not tell you. Okay, here's an example of the main function. Exactly one and only one function can be made. If you have several main, your program will fail right away. Okay, so if your compiler finds more than one main, it will be like, nope, I do not know which one to run. Remove one. Keep only one. The main must return an integer 0, like I said. and zero-terror system is successful. Okay, so hold on. All right, so many of you have taken more than C, right? Some of you may have taken Python, yeah? Python and some other languages is different than C and C++ or Java by something we call type checking. Each variable in C++ needs to be defined the type and the value that you want that to be. Comparing to some other languages, Python, Ruby, JavaScript, those have dynamic type checking, meaning that it doesn't require the programmer to tell your compiler what type is this variable. If you assign it a number 5, it will think it's integer. If you assign 3.5, it knows it's a float. So it takes time for those programs to figure that out, right? So if you just write I equals to 5, Python will go in, we call it interpret that line, and be like, oh, I is an integer and I is 5. C++ is not going to guess. You have to tell it what type it is. If it's an integer, you have to specify it. If it's a float, you specify it. That's called static type checking, which is a little different than Python, Ruby, JavaScript, for dynamic checking. That is also why C++ is a million times faster. Okay? But Python is probably a million times faster to write. So a lot of people like to write Python because you write 10 lines of code, it runs something that's equivalent to 100 lines of code in C++. However, when you calculate the runtime, the execution time, you find that C++ is a lot faster because it doesn't need to interpret, is this an integer? Is this a float? Oh, it's 5, so it must be integer. Wait, the second line says 3.5, it must be float. It's spending time to interpret your code. C++ doesn't need to do that, right? So when you look at your code, oh, integer, integer, this. Put in this memory and run it. Because of that, it's actually very common. So for those of you who took Python or are planning to take Python, still very much recommended. A lot of the people who are software engineers who write C++, Java, C# in their day-to-day work use Python to interview. Okay? Because in the interview time, you're like, write this program. You're like, okay, I can done in 15 lines. I don't care how long it takes to run, but I finish that in 15 lines. So it's beneficial to have both. Right? Don't be like, oh, I learned C++, I don't need Python. No. Okay? But I still use both. Because it's static type checking, let's look at the types. Here are some types that with the size that of each of the types. Char is what you use a lot in C, I believe, right? In this class, you actually will not be using that. You'll be using a class that's provided in the standard library called string. Okay, it's not char. So I'll show you how string is very helpful. Boolean, you're familiar with that, true or false. Integer and long, both holding numbers. One holds smaller, 32 bits, and one has larger memory to hold even bigger number, 64 bits. Similar to float and double, both for decimal places number, but one is smaller and one is bigger, so you can hold bigger decimal places. You can actually get those size printed in your program. And the way you do that is you do size of integer, size of float, size of long. So once we finish that one, you can try that. All right, the following will be reviewed. You should already learn this in C, so I'm going to go pretty quickly about it. Statements. In C++, similar to C, you need the semicolon. I know Python you don't. So if you're taking both at the same time, I sometimes do see people submit an uncompatible project that's written in Python-like language. I'll be like, oh God, this student is taking Python at the same time. You do need the semicolon for C++. Okay, so remember that and try to compile code before you submit. To avoid this type. Code block, I use this term a lot, right? When you have code that's in the curly brackets, I say this is a code block. That's code block. That's what I use for this class. The thing that I like the most is if statements. We also have switch statement if you like. If statement, you have the if with the condition, right? And then the statement in the code blocks, and you have else if, you have else. Switch statement checked by value, single value, right? So if this variable is 1, is 0, is -1, then it will do something for each case. We will use if statement a lot more than switch. This way. Loops. This is another way to tell people's signature, right? As a software engineer, some people really like while loop. Some people really like for loop, like me. Some people also do the do while loop. You can achieve the same thing for while loop and for loop, right? It's basically a way for you to control how many times you want your loop to run. I really like for loop because it's very, very specific. It tells me what counter I wanted to start with, when I wanted to stop, and how I wanted to count. I really like that, it's very clear, but it's up to you. The last thing I want to see is everyone come out from my class have my signature, okay? Develop your own, whatever you like. I will not be like, you use for loop for this. I will not do that. I'll be like, I want you to calculate this. You figure out how you want to do it. You can use while loop, which is a looser way to count. It doesn't require you to have a starting value, but most of the people have that before they start a while loop. They'll have int a equal to 0. And then they have their while loop with a stopping condition and how they want to increment. So you can see it's the same thing, right? Do while loop is a little bit different because it runs before it checks. That's the only difference between the other two. But same thing, you have a counter, you have a stopping condition, you have a statement of how you want that to count. Alright. Functions, a couple of new terms that you may hear me say. Function signature. What's the function signature? That is the function name with the parameter list. Okay, so the function starts with a return type, a function name, a parameter list, and then code block. Alright? And everything from here to here is called function signature. It's called signature for a reason. In the later on, I'll actually tell you what those signatures are. That is the way your compilers understand and distinguish between functions. Alright. Declaration and definition. For C++, you don't have to have definition before main. So let me zoom in here. On the left, it's how you will normally write this function. You have a function called square. It takes in a parameter a. It returns a times a. Okay? And then inside your main function, you call this, right? You do square 5. That should give you 25. That's how normally you write it. You can write it this way, which is you have the function return type and signature at the beginning before main. You can directly call it and implement it later or in another file, which we'll talk about later on. Is how we split files. This top one without definition, it's called declaration, versus down here is the definition of how it actually works, right? Declaration is what compiler use to know how to trigger this function. The compiler just needs to know the function called square. It takes in an integer. So that's all enough, right? Because when you call it, you do square 5. You need to check whether 5 is an integer. If it is, it's all good. As for how it actually runs the logic inside the function definition, it can go somewhere else, it can go later. Also, this is declaration and definition can be separated.
Question.
Yeah.
That one is a function prototype?
Yes, yes, that's right, yes. We'll talk about prototype in more detail when we talk about functions, but it's kind of a review, overview of what the preprocessor directives are all your include statements. Include statements need to happen at the beginning of your C++ program. Okay, at the top, you see here's an example. The things you include, there could be two things. One is libraries. That's from the C++ standard library, which is provided to you that you can use right away. Another thing you can include is your own code. So later on, I'm going to teach you how to separate your code into different files. You can then include your own file in this main function. Okay? Include this class that I just wrote. So this include statement are altogether called process. Namespace. Just like your namespace. So namespace is something that we use to avoid conflicts of names. Imagine that we don't have namespace. C++ have been here for 40-something years. I guarantee whatever function name that you can think of right now, someone already implemented. And you cannot implement it again because there's conflicts. So namespace is what helps you to distinguish it. We do have the standard namespace, which is std. So a lot of the things that we use was implemented by someone else inside the std namespace. We just use it as it. We don't re-implement it. Right? We just call it, grab it, and use it. For this class and this class only, we will have this using namespace std statement up here for your program. That is because for all your project assignments, all the functions that I will be asking you to run will be from the std namespace. This is not recommended after this class when you go to industry, when you write your code with a company. Most of the time, they have their own namespace, and you'll be switching namespace inside functions. So if you do this using namespace std at the very top, and you wrote 20 lines of code, another programmer come in, they will not like you. You'll be like, why? I don't want to use std. I want to use something else. Why do you define it for me? So a lot of the time, we don't recommend, like now in the industry, we don't have people have just this blank statement of using namespace std for the whole file, because they will be switching. But for this class, you're fine. If you want to practice, feel free to do so. You can not use this line number 2, meaning that every time you call a keyword or a term from std like this, you need to have std column, okay, at the front. Right here, std column, like right here, top here. So this is the one that you can write without using namespace std. If you don't want the hassle of putting that for every single term that you use from std library, then you can just have using namespace std. It's fine for this class. Okay, you can do that. All right, snipping into object-oriented programming. So what is an object? Objects are what C++ used to group components of a software so that it can be reused. Okay? Think of a building block. You build a block that's square and purple, and someone else wants another block for their building that's square and purple. They don't need to go make a box that's square and purple. They can just use your object and then create it for theirs. So an example, when I make the slide, Cybertruck is behind. So here you go. This very old, outdated example. So if you have an object that is Cybertruck, what you want for that object, the functionality and the attribute for that object will be what color of the car is, what's the power, what's the mileage of this car, and so on. For behavior of this object, you want it to be able to start, accelerate, stop, and turn. Okay, as simple as that. We don't want it to self-drive. Okay, so just start, accelerate, turn, and stop. Now, if you have another car, which is not shown on this slide, I'm going to go back to this slide. So you have another car that is Nissan Rogue, which is right there. That car also has color, right? Also has power, also has its own mileage. It should also be able to start, accelerate, turn, and stop, right? So for many, many cars that people define in their program, for example, they're trying to write a game, car racing. You don't want them to, every time they implement the function, how do I start this car? How do I accelerate this car? How do I stop it? How do I turn? You want that to be once implemented and stored somewhere that every single car can use that just for different color, different mileage, different power, right? that's the reusability of an object. And this is an example of how we define an object class, car, of class of C++. So in C++, we use something called class to define the blueprint or the structure of potential objects, right? So objects like the Cybertruck, the Nissan, Toyota, or all the other cars, those are objects. And this is classes, right? Classes is what define attributes and behavior of all those cars. We will spend 3 weeks, as you saw in the module review, right, on classes. This is just to show you what it will look like. Class car, that is a class name. Here's are the function of this class, start, acceleration, turn, stop. And then we also will have attributes, color, mount age, power, right, of a car. So you can think of this as a blueprint of all the car objects that you later going to define in your project. And then once you have that, you can have many cars. Okay, you can use this same thing to define. Oh, here is example of Cybertruck. We have Toyota Corolla, right? All those will just be from here. You don't define it over and over. Define it once, you use it with all your cars. Now you're saying, well, I know all the other cars can start, accelerate, turn, and stop, but my Cybertruck can auto drive. How do I add that? In the later of the semester, we'll teach you how to modify a base class to add in more and more functionality, still without re-implementing the things that you already have. Okay, so yes, you can do that. All right, finally, C++ development environments. There are actually 6 steps for your computer to compile your code. It all happens in milliseconds that you won't even notice. But this is what's happening underneath. We have editing, that's what you're doing, right? You open up VS Code or Visual Studio, you added your program. When you're done editing, one thing very important that I actually highlighted over here, I know the color doesn't show, of course it doesn't. Save your program to disk. Because every time you run your program, your compiler is trying to pick up from a disk. If you are writing without saving, it's not saved in disk. So at the very beginning, people will come and ask me, oh, my code doesn't run, but I have it all nicely written out. I will show you later on in the lab 1 of there is a small indicator on your VS Code interface to tell you that your file is not saved. The minute I see it, I know that you have not saved your file. So it's not what's being run. The code that's broken is probably like multiple versions before you got to the final version. So please remember to save your file before you run your code. This is such a common thing that save is Control-S for Windows and Command-S for Mac. So see, a lot of people, when you first start to be a programmer, you will go File, and then you click Find Word, save this, and then you click that. I save my things like every 5 minutes, and sometimes I'm writing a website or filling a form, and I'll automatically Control-S to try to save and be like, no, you cannot save this website. It is so common, it becomes a habit for software engineer because everything needs to run from disk. Okay? So I'm telling you right now, Windows, Control-S is your friend. Mac, Command-S is your friend. That's saving it. And then you run, you'll be running.
Question.
Yes.
So VS Code has an autosave feature. Do you recommend turning that on or manually do it?
That's a good question. Is that, do you trust yourself? Say that you write a program that runs fine and you'd be like, okay, I'm adding a function. And then everything breaks. Okay? If you turn on autosave, right, it will be auto-saving without going back. I know VS Code for a period of time you can undo, which is Control-Z. I don't want to tell you how I know that. But you can undo for a limited amount of code typing only. So I do not have the autosave turned on.
I see.
That becomes a habit of me. I see a lot of my peers do that. It's just keep trying to do Control S on things that they cannot save. I still recommend that to be something that you control. It's when you want to save this. If we have time this semester, I do like to provide some like extra non-required contents for C++. One of them is version control. Okay, so one of you asked me about like repos, and that's part of the concept of version control. Is where your code is running fine, you save this version, and then you do your things. It breaks, it's fine. I have running version safely somewhere, so you can safely then write your things. Then yeah, maybe at that point autosave is safe because you always have your running version tucked away somewhere safely without losing it. It's up to you. Right? Everyone's habits different. It's up to you. All right. So editing and saving. Next step, pre-process. A preprocessor will execute automatically before compiling. It includes other text files to be compiled first or perform various text replacements. This is also something that happens under, like, behind the scene. You will sometimes see you type something, right? And without compiling, it turns red. That's part of compiler, where you'd be like, this is a syntax error. Without you even compiling, it will know, okay? It sometimes will, Visual Studio is very good with text replacement. That's why it's so forgiving, right? Be like, this is wrong, I'm gonna secretly replace the right thing for this programmer. Doesn't happen in VS Code, all right? Processing, and then compile. Compiling means that your compiler is translating the code that you write in C++ language into a machine-readable language. We call it object code, that you won't be able to read it as C++ anymore. Okay, so that's compiling. Only Java, C, C++ call it compiling. Python, JavaScript, R call it interpreting. Right? So we talked about a little bit about this, so now you know why. Why do we not call it compiling? Because it's not compiling, it's interpreting your code. So for C++, it's called compiling. Link. After compile, remember to include the preprocessing directives is where you will include this file in your main function and include that library in your function. This is where it's all linked together. If you refer to another library in your code, you will try to link that. It doesn't link all the library because it's huge. You only link the ones that you specify in your code that you want to use. After linked, something called an executable image is produced. Okay? So in the lab, I will show you what happened in VS Code when you click compile. A new file will pop up in your folder. Don't go in and be like, oh my god, malware, delete it. No. That is the executable image will automatically generate it, which it looks like a malware because you really cannot read it. You open it and be like, this is so spam. Okay? That is an executable image automatically provided by your compiler the minute you click compile. Every time you change your code, you compile again, the over will be overridden. So the new executable image will be placed there. So we'll show you the detail in the lab. So that image is there, saved on disk, and then loaded. So similar to how it loads your C++ program from your disk, it also loads the executable image from the disk, from your disk as well. So that's the last step before executing, because you need to load something that your machine can understand, and then finally run that. Okay? So I know that all happens behind the scene when you just click run, and all this will happen. Okay. All right, that's the end of the intro to C++. We'll talk about lab 1. So if you do have your computer with you, your laptop with you, feel free to boot that up. And the lab will ask you to follow along. For both Windows and Mac, I'll do both versions. Okay? And feel free to take a break right now. You can come back at 7. How about 7 minutes? Yes, so someone remind me there's a tutorial or things that I linked in one of the page called installing VS Code. That's what we're going over right now. So if you have trouble with that, don't worry. But if you finish that, you don't need to stay, right? Oh, actually, I lied. There's something that I think will be helpful for you. That's not required for this class, but I had major trouble after I transferred because I didn't learn that in IBC. So I put it next. So if those of you who want to learn it, you can learn it. Yes?
When did you go to IBC?
When did I go to IBC? That's a good question.
Cannot recall.
Long time ago.
We know she teaches at IBC now.
Chandler was my professor when I was in school. Whoever is teaching 41, I think he also taught me 41, data structure.
What was?
Yes, I think he did. He's also a part-time professor, right?
Yeah, I'm
Yeah.
taking him for data structure.
Yeah. He's also a
Chandler?
professor. What?
Which professor?
You remember which professor is?
What was?
Oh. I think. Remember? When I was in school, I wasn't like successing every class. I tried 41, I dropped it twice. Too hard for me. I tried after Java, I'd be like, I got this. And when I'd be like, nope, dropped. Come back, took C, I got this. When nope, came back up, took C++, I have to get this, now I need to transfer. And then I took that class and I passed. So if you're having trouble with any classes, you know what? One day you may be coming back and teach me. All right, VS Code. So other than what I actually covered at the beginning of the class on VS Code and why I chose it, another thing that I really like VS Code, also why so many industries are trying to use it now, is because it's open source. What does that mean? There are a lot of software that is not developed by one company and one company only. Okay, a lot of the time, like Microsoft, who developed this, a group of their programmers probably did that a long time ago. That's only a group of people. The minute you open source a tool that potentially could be helpful, useful for software engineers around the world can contribute and make it better. VS Code is one of the compilers for that, meaning that there's millions of applications in VS Code that you can install, VS Code that you can install that's not developed by Microsoft anymore. Developed by some user they haven't heard of, but have like hundreds, millions of stars, meaning that, oh, everyone find it useful and they install it. That's the power of open source. Once you learn C++ and once you learn Java, when you're getting more and more comfortable with developing programs, you can even start contributing to some of the open source, which is a great plus actually for your resume, right? When people are trying to hire a software engineer, if they see someone who contributes to open source, it will stand out. So VS Code is open source. You can already see through the screenshot that I took earlier. Some of the top extension that is developed by we today. Like some software engineer, ESEMP, I don't know how to read it. Another software engineer that has been downloaded 7 million times, right? USA, 9 million downloads. That person. I'm not even going. But there's also Microsoft, right? Microsoft VS Code team developed this. Microsoft Python team developed this. Like this is from Red Hat developed this. Microsoft.NET Tools team developed that. So company can also contribute to open source, and companies are very proud to do that as well. All right, VS Code. So interface overview. Again, this is Mac interface, but I assume Windows would not be that much of a difference. On the left are kind of the tags, right? So the first one is File Explorer. The second one is what you use to search across all your projects. Source control. This is not covering this class, but if we have time, say I have an extra week or something, we can go over it. Actually, that that was recorded last semester. So even though we don't have time for it, I'll publish on Canvas. The people who are interested in just looking at the recording can go ahead and learn word control. This one is launch and debug, okay, which is different than run, which we'll show you. And finally, manage extensions. This is where you could see all the extensions that people from around the world debug. All right. First thing is open up the VS Code that you freshly installed. Go to extension, which is the fifth one. Third one for me. You may have more. Okay. That's something that looks like this. This square thing. This one is the extension. So something that looks like that is extension. Click that. In the search bar on the top, find C and C++ developed by Microsoft. Okay. Once you find that, click install. Once you have that, search for code space runner and install that. Developed by Jun Han. And do that. Let's install that. It's very helpful. Okay, so those are the two extensions that we need for project 1 and 2. Alright, once you finish installing, you will see this turn into uninstall. Do not click that. For both of them, they need to be installed. Once it's installed, it should, under this little section called enable, there should be another one that is either recommended and active install, so don't worry about that. Don't go crazy at extensions. Fair warning, they could conflict with each other. Okay? Some people's compiler doesn't work in the middle of the semester. Come ask me like, oh, CodeRunner doesn't work. I'd be like, show me your CodeRunner, and he has like 30 something in there. I really don't know how to help. Right? Extensions, like you saw, are developed by different developers. They don't care about their conflicting with other people's extension. Okay? So don't be like, oh, this is recommended, install. Oh, this is also recommended, install. The more you install, the harder when you have trouble with some of them to debug it because they all are like use the same thing and need to be with each other. Alright, so you just need those two, CodeRunner and C++. Alright? Once you have those two installed, go to find terminal. The Mac user is on the top, actually outside of the window. There's a terminal, and you click new terminal. For the Windows user, it should be on the top of your window. Okay. New terminal. Once you click that, this will show up at the bottom of your VS Code. Okay, something called terminal here at the bottom. For Mac users, inside the terminal, which is at the bottom of your VS Code, hyphen CLANG space, 1 space, 2 dashes, version. Press enter. After you press enter, if there's a version number successfully showing, you can skip the next 6 slides or something like that. If you don't, you want to run xcode -select space -- install to install select. Okay? After you finish installing that, run that again. You install until you got a correct version printed out. When you do clang space -- version. Right? Now, so if I'm going to zoom out here, the following 1, 2, 3, 4 slides are for Windows user. Okay? So Mac user, you will have an easier time to install things because Mac is more open to you. But I used Mac for all the years I was in school. The minute I graduated, I was asked to switch to Windows. Windows is a lot more common and popular in industry. So I know Windows user, you may suffer for the next 10 minutes, but it's worth it, okay? I suffered this after I graduated, so it's the same thing. All right, Windows. For Windows user, most of you will not have this installed. So unless you have the programming in the past on that same machine, in the terminal you can try to type in G++ space -- version to see whether there's a version successful for that. And also do gdb space -- version. Okay. If you have versions outputted, you're also good to go. But for those of you who do not have a version, you want to download something called MSys2. So this link that you can click, you should all have the slides. Okay, it's already on Canvas. You can download, you can click it. You can all go to here and you can install something called MSys2, which is a package management to help you install GCC. Alright, so go to this link, install MSys2 on your computer, and then there's 5 steps. Oh, that's, I think the 5 steps are for you to install. Right. Yeah, the first 5 steps is telling you how to install. So yeah, install it, right, download, run it, find the right install folder. When it's done, click finish, and then the terminal for MSys2 should pop up. So those are the first 5 steps, which is just installing MSys2. Once you install MSys2, Windows user, you will not be using your VS Code to install packages different than Mac. Okay, you will use MSys2 to install packages. What we want to install is right here. So step 6, which is hidden here, is that you want to copy and paste this into MSys2 and run it. It will install everything you need. While it's installing, you want to monitor it though, because it will ask, do you want to proceed? If you don't type anything, it'll be like, oh, you don't want to proceed, never mind, quit. Okay? So watch it. It will ask you, type Y or N if you want to install. Type Y, enter. And then it will continue. After a bit, it will be asking you again, do you want to continue? Make sure you do Y and enter. So watch it to make sure it's finished installing successfully. Once that's done, you should be able to, in the same place, in MSys2, type gcc space -- version. Okay, this is not in VS Code, it's in your MSys2 terminal. Type that, it should give you a version number. Right? Follow that. Actually, they stay here. So 1 to 5 to install, 6 is copy and paste this, 7 is once that's all finished, do gcc space -- version to make sure a version number shows up. Now this slide is the one that's most complicated for Windows. Windows hide away their system environment like environment path. So for you to enable VS Code to use GCC, which you just installed, you need to add this path into your system variable. So once you have it on install, you need to first find where it is. After you install MSys2, by default, it should be in your C drive for Windows. Okay? Go in C drive, see whether you can find it. If not, try program files. If not, try program files x86. It could be any of those. So find this folder, MSys64. Inside this folder, make sure you have mingw64. If you don't have it, or if your mgw64 is empty, that means that you missed a yes continue checks. Okay, go back to MSys2, try to run it again, monitor it. Make sure you always press yes for every single thing. Once they all installed, there should be a bin folder in MGW64 inside MSys64. Okay? Go into the folder bin. That is the path you want to copy. Okay, the path would be something like C. Like for me, it's C, MSys64, MGW64 bin. You may have like C program file, MSys64, something like that. Okay, so that's a little different. So find where your bin is, copy that path, and then add that to your environment path. For Windows, a little bit complicated. You go to your Windows starting menu and search settings. Once you search for settings, you will have something called added environment variables for your accounts show up in the search list on Windows. Click that. Tucked away in that is your path variable. Find that path variable, click edit, and paste this file, this C, MSys64, MGW64 bin, into that path. Click save, click apply, click save, done. Alright, once that is all done, over both Mac and Windows, restart your VS Code. Close it down. Mac people, please right click and actually quit that, because otherwise it will just be hidden away. That should apply all the changes that you just made to VS Code when you restart it. Alright, yes. Oh. If you need my help with any step, you can come to me after class. Or after I finish all this, I can come to you if you have a actually a step. Alright, so next, follow along. The followings, you don't have to install it to follow. So just, if you're still installing, so look up a little bit, because Mac users have been waiting for us. We want them to wait for you. Okay. So I just talked about the concept. Once you install, you will see all this. Okay? Alright, VS Code interface. Inside VS Code, all of the settings, right, are bounded to folders. Meaning that if you set everything today, you set it for folder lab 1, and then you close it, and tomorrow you create a new folder called lab 2, you open it up again, nothing is there. And you're going to panic, you're going to email me and be like, don't worry, it's there, it's in lab 1 folder. So how can we not have it only in lab 1 folder? Is I would recommend you create a CS37 folder and put all your things in there. So the setting that you're setting today will be bounded to CS37 folder and all the subfolders that's going to be in there. So you won't go into trouble of like, oh, I set this up for an hour, it's all gone, I'm not going to pass this class. You're fine, okay? So create a CS37 folder and all your settings will bound to that, and you just stick to it. In some case, you buy a Mac because you suffer today with Windows, not recommended, okay? And you want to redo it again, it's fine. You go to lab 1, just follow it again, okay? If you have a question, you can always come to me after class, after tomorrow's class as well, not tomorrow. Next week's class as well, I'll always be here, this will be fine, okay? Some people do change their computer in the middle of the semester. Labs are all going to be there. If you want to start, you just start from lab 1, and then lab 2, and then lab 3, and you get there, okay? Alright, create a folder, CI37. Someone just came to me and asked about OneDrive. Please don't do it in OneDrive. I tried, I felt miserable, okay? For some reason, VS Code is not really friendly with running code that's saved in a cloud drive. I spent an hour and I didn't figure it out and I gave up. Okay, so is there a way? Probably. Do I know? I don't know. So I just drag it out of my OneDrive, I run it, and it runs fine. So if you run into trouble because you have your things in OneDrive, Google Drive, try to move it out to your local, and then do it. Alright, so for that one, we're going to create a subfolder inside CS37 called lab1, and that's what we're going to operate in. Now in VS Code, so when I say create a folder, I mean I create on your computer. So don't worry about like, okay, how do I create this in VS Code? Like an actual folder on your machine. That's just like how you normally create a folder. You create outside of VS Code. Once you have that folder created, you can go into VS Code and then go to you can if this is the first time you open up VS Code, you should have this welcome page, and you can do like open folder. If you don't have welcome page, it's fine. It's under file as well. So just go to the menu. There should be an open folder. Click open folder. Find your CS37 folder. Don't find that one. Find CS37 folder. Open that, and everything inside will be listed on the left. Okay. So say that you restarted VS Code. When you open folder, make sure you always open the topmost level folder for CS37. Right? So open that. Then you'll see something like this on the left where it's called CS37. And then you can expand it, and you should see lab 1 in there. Later on you have lab 2. Later on you have project 1. Later on you have project 2. You'll see all the folders in here, which is in there, which is pretty neat. Alright? Okay. Your first C++ file will be 5 lines of code. Now, the way you create a new file, you can actually just hover over to the left. Hover over to the left here. There's a create new file, create new folder, and something else. There are 4 icons. If you hover over here, one of them is create file, that you can create a file in specific folder that you're clicking on, or you can just create it on your computer. It will sync, it will update. Up to you, I want you. One important thing about files that you created in this class, they all need to have the right extension. .cpp stands for C++ file. VS Code will color code your syntax, which is actually very friendly. I really like it. Well, it will color code things for me, so I know this is a return type, this is a function name. That is only applicable when it recognizes that you're writing C++, because all the other languages, color coding are different. So make sure your files have .cpp as the extension. All right, remember me talking about saving? This little white dot that you see probably right now on the top of your file name means that your file is not saved. After you click Ctrl S or Command S, that will disappear. It'll be like this. Okay, so if you ever see your file with this white dot, that's because your file is not saved. When you run it, that's not going to run. Okay? So always check when you be like, oh, my file's not compiling now. What happened to all the changes? I already fixed this. Well, check whether you have the white circle. That means your file is not yet saved. Alright, so just type those in. It's a very simple name. I just want you to test that your compiler is all set up correctly, that you can actually run your first program. And then, that's what you type in, right? Include statement, main. Oops, this is a typo. There's 2 columns, std column C out, welcome to C++, return 0, semicolon, close. On the top right, there's this icon. This is run. Okay, run as in just run as it is all at once, which is different than what you sometimes will hear debugging. We'll talk about debug in lab 2, which will happen next week. Okay? After you click run, if you set up everything correctly, at the bottom of the screen should be your output, like this. Welcome to C++. We'll get it up. Okay, that is what you know that, oh, I set up everything correctly. It's running. However, we have another configuration that we're going to do. Because output only show you what you picked. The next week, or the week after that, we'll teach you input and output. Okay? So output only do output, like it's in the name. Terminal allow input and output. So we don't want you to just stick with output. We want you to actually be able to use terminal where you can do input and output. And the way you do that, so you go to File if you're Windows, Preference if you're a Mac, go into Settings. Now everything that we added in the settings are bounded to the folder CS37. Okay, if you spawn another folder, the setting is gone. You have to reset it. So go to Settings. There will be a search bar in the middle of the screen. Type in code-runner space terminal. You will have something called code-runner column run in terminal show up with this box checked by default saying whether to run code in integrated terminal. Please check that so that your code will be run in terminal instead of output. Mean that next week you can try input. Alright, so once you check that, you can close the tab. Now you go to the top right and click that run again for the welcome.c++. You will see it show up in the terminal here. So that will highlight here. Terminal will be highlighted instead of output. Output will be gray out, meaning that everything now runs in terminal, not in output. Right? Okay, this is something that tricked me so hard outside of school. In IVC, you're allowed to use VS Code, Visual Studio, Beans for Java or something. You're allowed to use compiler, basically. You have a nice interface, you can add it. And when I transfer to use it, there you go. No more IDEs allowed. Okay. All people are allowed to do is to run your code from terminal and terminal only, meaning that you open up your Mac terminal on your Mac or you open up your Windows terminal, I think it's called terminal, on your Windows. All you're allowed to do is type things in there to run and compile code. So we're not doing that. We're not being like, you're not allowed to use IDE. So we still want you to focus on writing the C++ and do not worry about, still use the help that IDE can provide. But just in case, UC still asking students to not use IDE when they start, I want to tell you what's happening when you click that run. Meaning that if you are asked to do this, you just type that in, it's exactly the same thing. Okay? So what are those? 3 things that happen automatically. So by the way, this screenshot was it's basically from here. So whenever you run, it will show you what happened underneath. It's just before I never care or bother to look at it. Okay? And now I know what those means. Let me tell you how it's being run. So the first thing is CD. In terminal, CD means that go into a folder or find a folder. So when it has CD, a username, the username desktop, C37.1, that is the path to my project file. Okay? So that happens first, is find where my program is. The second box with 2 ampersand means that run this and then run this. This is compiling. G++ is what we use in Mac that we just installed for the C++. So G++ will compile this file called welcome.c++. -O is output an executable image called welcome. this is the machine code that we're talking about, right? The executable image that your computer used to run your program. Not your C++ code. Computer doesn't recognize that. It compile it down using G++. You compile your C++ code down into this executable image called welcome. -O is the name, right? -O, output, meaning output. Okay, so if I read this, G++, compile welcome.cpp, output a file named welcome. Yeah? So that's what that means. And then finally, run this executable image, welcome, which was generated from the second step. In Mac, when you run the executable image, you just put that image in. Okay? This is the path of the image, and this is the image. Because it's runnable, you put that path in, press enter, it will run. Alright? So that is, behind the scene, a terminal look. That's also why when you finish clicking the run, you will notice that in your folder, this file will show up. That's the executable image. Okay? Automatically populated by C++. Right? That's it for today. For those of you who have finished all of those, you are free to go. Oh, by the way, some people asking about recording. Labs, projects are not recorded. Okay? Only lectures. Lecture notes, right? The intro to C++, that's all recorded. So those will all be published. Labs, because it takes a long time and so some of the questions that if I record it, it's going to be 2 hours. And so I do not record labs. But they are all going to be published on Canvas. Lab 1 is already up.